Alright, examine the graphs of each relation below. Decide if each is a function, then describe the domain and range of each one. So in order to be a function, remember, each x value has only one y value. So to be a function, each x value has only one y value. So if we look at this one right here, I see that for x equals 0, which is the y-axis, I've got y values right here, right there, and right there. So this is not a function. The domain are the possible x values. So here, this function, or this graph, it's not a function, goes between -3 and +3. So we say that the domain is -3 is less than or equal to x less than or equal to +3. The range is the possible y values. So the smallest y value is -3, and the biggest is +3. For this graph, I look at all my x values, and I see that the graph only has one y value for each x value, so it is a function. The domain goes from right here, -2, and it's in a closed circle, so less than or equal to x, all the way over here to 3. Again, it's a closed circle, so we have less than or equal to 3. The range, the smallest point is down here. That's at y equals -2. And the highest point is up here at y equals 2. Yesterday, Micah was given some information and was asked to find a linear equation. But last night, her cat destroyed most of the information. All she has left is the table below and a graph with the point -3, 3. So -3, 1, 2, 3, 1, 2, 3. Complete the table and graph the line. So I can put when x is -3, y is 3. When x is -2, y is 1. So I see that we're going down 2. I know that this is linear. So our difference is going to be the same every time. So we're going to go down 2 again to -1, down 2 to -3, -5, -7, -9. So each time we go over 1 and down 2. So here's our line. That's okay. Micah thinks the equation for this graph could be 2x plus y equals 3. Is she correct? Explain why or why not, and if not, find the correct equation. So we need to know if this is we need to put this into y equals mx plus b form. 2x plus y equals 3. So to do that, we're going to have to subtract 2x from both sides. So we get y equals -2x plus 3. So that means that if this is correct, this slope should be -2. So we go down 2 and over 1. So the slope is right. The y-intercept is +3. That's not true. That's wrong. The y-intercept should not be +3. It should be -3. So the correct equation is y equals -2x minus 3. Kevin and his little sister Katie are trying to solve the system of equations shown below using the substitution method. Kevin thinks the new equation should be this, while Katie thinks it should be that. Who is correct and why? So before even looking at their equations, I'm going to try to solve this problem myself using the substitution method. So I see that we have here y equals 6x minus 1. So because that equals y, it's the same thing as y, I can plug that into y in the second equation. So my new equation would be 3x plus 2 times, instead of writing y, I'm going to write 6x minus 1 equals 43. Now let's see whose equation that matches. This is 3 times 6x minus 1. That's not right. 3x plus 2 times 6x minus 1 equals 43. So it matches Katie's equation. So Katie is right because she substituted 6x minus 1 for y in the second equation. Kevin made a mistake because, remember that stands for because, he substituted 6x minus 1 in for x instead of in for y. Complete each of the diamond problems shown below. And remember, the pattern is if we have x and y on the sides, we multiply to make the top and we add to make the bottom. So we want to know 3/4 times something equals 1. So I know that when I multiply fractions, I would do 3/4 times something over something equals 1. Remember, when we multiply fractions, we do numerator times numerator and denominator times denominator. So I have to think about what number can I multiply here to get 1 on this side. And remember, to get 1, I have to have the same number on top and the same number on the bottom. It means we have the same number of parts out of the whole. So I know if I multiply 3 times 4 and 4 times 3, I'm going to get 3 times 4 is 12, 4 times 3 is 12. 12 over 12 equals 1. So here I can have 4/3. If I'm going to add fractions, remember, to add fractions you need a common denominator. So 3/4 plus 4/3. You have to have the same size pieces. Right now we're in fourths on this fraction and we're in thirds on that fraction. We want our pieces to be the same size. So to find a common denominator, we can use 12 because 12 goes into, or 4 goes into 12 and 3 goes into 12. So to change this to 12, we multiply by 3 over 3. 3 times 3 is 9. 4 times 3 is 12, so that's 9/12. Plus, here we have to multiply by 4 over 4. 16/12. So now we have the same size pieces. We're in twelfths. We have 9/12 plus 16/12 gives us 25/12. Two numbers that multiply to make 6 and add to make 5. 3 and 2. A number that multiplies with -1 to make 5. So I know that any number times 1 is going to be itself, but I want a negative times a negative to make this 5 positive, so it's going to be -5. -5 minus 1 is -6. A number that adds with 6 to make 4. So it's getting smaller, so we're going to have to add a negative. So 2. 6 times -2 is -12. All right, last problem. What we did at the very end of last semester, graph the following system of inequalities on the coordinate plane. So there's a couple of things we need to remember when we graph a system of inequalities. First, we want to graph the inequality, which will be a line first. This is equal to, so we'll have a solid line. So let's do that first. 3x plus 4, so we start at 0, 4. Our slope is 3. So we go up 3 and to the right 1. We know we have a solid line, so we can draw that line solid. And then we want y values that are less than this line. So y values that are less than the line, we can put our pencil on the line. We want the ones below. These y values below the line. Here we have y is greater than negative 2/5 x minus 3. So there is no equal sign here, so this is going to be a dashed line. We're going to start at 0, negative 3. And our slope is negative 2/5, so we go down 2 and to the right 5. And we draw our dashed line. And we want the y values that are greater than the line. So we can put our pencil on the line and shade up. And remember, the solution to a system of inequalities is where both inequalities are true. So that's this section right here. We'll shade that a little bit darker to show that that's the solution. All of these points make both of these inequalities true.